So this video is about how to read an RFC, or Request for Comments, the standards document of the IETF, of the internet. So reading RFCs is critical if you want to get a deeper understanding of how the internet works, how its protocols are specified. But they're a document that's evolved over several decades to have certain structures and certain approaches, and this video is going to explain what that looks like and why. There's actually an RFC, a Request for Comments, 2555, which describes the history of RFCs, sort of a historical retrospective. The first RFC, RFC1, was entitled Host Software. And this quote from RFC1 talks about where that name came from, the idea that these documents aren't statements of control or assertion of control, but rather part of a dialogue. And while RFCs today are a bit more formal than this first one, some thoughts on how to structure host software, that still remains. There's nobody who enforces RFCs. Rather, they're statements of a group of people about what you need to do to interoperate. You can always write things that don't follow RFCs, but if you want to interoperate, this is what you do need to do. So over time, RFCs have come to have a standardized format. So there's the structure of the document, concerns of intellectual property, and also specific terms that RFCs use. Often you see them in capital words that have capital letters that have very specific meaning, are all defined in RFC 2119. Modern RFCs, for example, are required to have two sections, security considerations and considerations for IANA. So security has obvious reasons. IANA is if this RFC needs new value registries, say protocol fields, or whether it allocates fields in other protocols. Now, one thing that often a first-time reader doesn't quite realize, and it can be a bit confusing, is that there are actually multiple types of RFCs. And they actually have very different meanings and very different implications towards the standards process of the internet. So for example, there are proposed standards, standards track, informational, experimental, and best current practice. And the way to think of those is there's a spectrum of whether or not there's an idea a couple people have proposed, say experimental, whether or not it's a specification or it's simply some valuable information. That's an informational RFC, can be not a protocol, but rather just some valuable information for the community. Then you have proposed standards. So here's something which a group of people believe should become a common standard of the internet. And then standards track. And the transition between proposed standard and standards track, where standards track is sort of further along the process towards becoming a really stable standard of the internet, has to do with how many implementations there are, whether they can interoperate, and there's some formal process for making that transition. There are also RFCs that are best current practice, which state, based on our current knowledge today, these are the things that you really want to do, best practices. So for example, there are best current practices about how to implement TCP and its congestion control algorithms. So that's what an RFC looks like. This is the basic process that an RFC takes, or a document takes to become an RFC. This is a bit simplified. And this is actually my personal experience when working on the RFC for this algorithm that came out of my research, Trickle. And so generally what happens is that the document starts as a draft. And so when you see documents in the IETF named draft, they are not RFCs. They are not formal documents. Instead, they are works in progress, and correspondingly, they actually time out. So if people don't update the draft, eventually it disappears off the IETF servers. And so you start with a draft. You notice that it's draft-levis. This means that it's a personal draft. It's a personal submission that somebody, just a person, or maybe a few people, are suggesting this document might be of interest to the internet. And then there's some information. In this case, Levis, that's me. Role was the IETF working group that the draft was being proposed for, the routing over low power and lossy links. And then a descriptive name, Trickle, the Trickle algorithm. And then a number. So this is version 0 of this draft, so the first version of it. Then you can submit that to a working group for some consideration, discussion. Maybe it iterates a couple of times, you make some improvements, some modifications, and the numbers increment. So Trickle 00, Trickle 01, Trickle 02. Then at some point, the chair of a working group can say, or ask the working group, do we think that this is something which should become a working group work item? That is this a document or an idea or a protocol which the working group thinks is part of its charter and should make more formal? When it becomes a working group document, then the name changes from draft someone's name, Draft Levis, to Draft IETF to show that this is now a document under the full auspices of a working group. And you can see then it's still the role working group. At this point, the version number resets to 00. Then it goes through revisions. You present it at working group meetings. You get feedback, comments on the mailing lists, questions, concerns. The document iterates over versions, 01, 02, 03. At some point, the working group chair, or one of the working group chairs, they decide that the document is ready for publication. And so the working group chair can say, look, I feel like this document's been through a lot of revision. We agree. It seems like it's a good position. It's something that's part of the working group's work. We want to make this an RFC. At that point, there's a last call issued, first to the working group and then to the IETF. So the working group is given a chance, a period to respond to any final comments to improve the document, after which then it's given a last call to the entire IETF. Anyone can comment on it and suggest things to improve it. After it's passed through those last calls, that is, all of the issues which people have seen have been addressed to the satisfaction of the working group chair, it goes to the IESG, the steering group, the Internet Engineering Steering Group, which has representatives from all of the major areas of the internet. So you have both tremendous depth, people who are, say, experts in transport, experts in real-time application infrastructure. But then, because it's all of the experts, it also has tremendous breadth, everything from the network to operations to transport. So the IESG reviews it, gives feedback, gives comments. Sometimes they refuse to publish it as an RFC. They say that this has substantive issues which we see. You need to completely rework it. But if things go well, the IESG gives some comments, you address those comments, and then the document is approved as an RFC, a request for comments. So as described in RFC 2119, there are certain terms which are used in RFCs which have very specific meanings with respect to interoperability and proposed standards. And so these are those terms, and when they're used in all caps. So the first is must, required, and shall. If you see this term used in an RFC, then this is an absolute requirement. If a protocol or an implementation does not follow this statement, then it does not follow the RFC. It is not compliant. Then there's should, recommended. And so the should and recommended are things you really generally want to do. It's really advised that you do it, but it's understood that there might be times when you don't for whatever reason. And so the terminology that's used in 2119 is that you really should understand the implications of not doing this if you're going to choose to not do it. And then finally, there's may optional. And so it's totally up to you. You can do it, you cannot do it. It is not required for interoperability in any way. And so when you read an RFC, it's important to see these terms and how they're used and then understand what the RFC is really saying you have to do to be compliant. So I thought as an example, we could walk through RFC 5681. This is TCP congestion control. As you can see, it's standards track. So this is pretty well along. And it was written back in 2009 by a bunch of folks who are bigwigs in the internet. And so one thing you can see is, in fact, the history of this document in terms of drafts. So it was draft IETF, and it went through all of these revisions, and you can see what the revisions are. The earlier revision that this obsoletes is 2581, and so this particular IETF draft went through 7 revisions before becoming an RFC. So let's go back to the RFC. So as you can see, there's an abstract sort of stating what it's about. There are copyright notice about intellectual property, some background. It defines a bunch of terms which are used in this. But if we jump forward, so here, say in section 3, it's defining the congestion control algorithms of TCP. Slow start, congestion avoidance, fast retransmit, and fast recovery. And so you note, for example, one of the first requirements this document states is that it's okay for a TCP sender to send more slowly than what these algorithms say in order to back off more aggressively to congestion, but it must not be more aggressive. That what this document describes are basically the upper bounds of what TCP should do. It should never send faster than this because to do so might cause a problem. So then here's another specification. It says the initial value of the congestion window. So when you start a TCP connection, what the congestion window's initial window is, it must be set following these parameters. So basically, if you have large segment sizes, then it should be 2 segments. If you have medium-sized segments, it can be up to 3 segments. And if you have small segments, it can be up to 4 segments. There's a statement of, if you want to follow TCP congestion control properly, here's what your initial segment size can be, the initial congestion window size. So those are examples of musts and must nots. Here's an example of a should. So this SS thresh is saying, what is the initial slow start threshold, the initial threshold at which we're going to transition from slow start to congestion avoidance. And so what this document says is the initial value should be very, very high, so that you just do slow start until essentially you get a loss, and then you drop into congestion avoidance. However, it can be smaller if you'd like, and so it should be set arbitrarily high, but you cannot set it arbitrarily high. You should understand, however, the implications of what will happen if you do this. Finally, here's an example of, in fact, a may and a should and a must not. So it's talking about when TCP is in congestion avoidance and it's incrementing its congestion window. It says, oh, you may increment congestion window by a certain number of bytes. In fact, you don't have to. You could just not if you want to. You could not increase it. But it should increment it once per RTT by this equation, and it must not increment it more than this amount. So this is basically saying, hey, here's the upper bound, and you should not ever do it more than that upper bound, but you generally want to follow this equation. You should follow this equation. So with all this aside, remember, so this document is saying something about how large the initial window size should be. It must be this number of segments, 2 segments for large segment sizes, 3 for medium size, 4 for small segments. But remember, this is just an RFC, right? You can say that somebody isn't compliant, but nobody is going to enforce it. In fact, if you look at this web page here, there's this really interesting blog post from about 2 years ago about how Google and Microsoft were not following this RFC. So if you want, you can look this up. This is Ben Strong's blog. If you search for Google Microsoft congestion window cheat. And essentially what he found is that when you first connect to Google or Microsoft sites, their initial window is significantly larger than 2. That is, they will send you more than 2 segments, essentially, so that they can send you their whole web page in just 1 round trip time and not having to wait for the congestion window to increase. And so he walks through kind of all the experimental evidence that he gathered, and he shows that these guys were not following the rules. Since there's been then discussion in the IETF about maybe we need to increase these sizes, networks are getting faster. But the point here being that just because it's written in an RFC and it says you must do something doesn't necessarily mean that everyone always does.